Hello everyone, welcome to my second physics lab. In today's lab, we're going to explore Newton's second law with the net force that is not constant or equal to zero. Recall that Newton's second law as a following formula. In our experiment, we expect an outcome of a velocity time graph as a curve, not a constant, not a straight line, because we're not expecting a constant net force. So the force system, our system will encounter mainly two forces. The one is gravity, second one is drag force, i.e. air resistance. This is a setup for today's experiment. I used a medicine box as my experimental object. I calibrated the tracker with the length of the box with approximately 10 centimeters. And I set the coordination center to be the center of the box. After that, I manually set each point of mass of each frame in the motion when the box is falling down. Here's the code segmentation for the model with the drag force and the gravity. As you can see here, I set the mass of the object roughly 200 grams and the proportionality constant roughly 0.05, which I personally think it is a bit higher than the actual value. And the F net here is combined as addition of the drag force and the gravity. I then updated velocity position by Newton's second law. For the code without consideration of the drag force, everything else is remain to be the same, but the B value, which should be the proportionality constant, is setting to be 0, so that no drag forces will be considered. Here is the comparison graph with the tracker model and the graph we're getting from the glow script model. The red line is getting from the glow script. As you can see, the first half of the graph is kind of consistent with each other. However, after the half of the time, there are a bit inconsistency here. The source of the inconsistency is mainly due to the box is hitting the ground. However, both of the lines is not a straight line, but a curved line, which indicating a non-constant net force. Here, this is a graph with a model without the consideration of the drag force, which means only gravity exists here. You can see a greater inconsistency here in this graph, as this is not a perfect simulation of the real situation or physics model. Now let's look at the terminal velocity. By reaching a terminal velocity, we means the velocity reach a constant non-changing state, which also refers to by Newton's second law that our net force is equal to 0. That is due to drag force to be the same magnitude or to be the same vector but in opposite direction as gravity, so that two forces cancel each other out. We have a 0 net force. Now let's look at by the model, what if an object is falling from rest or falling with the initial velocity of non-zero. The outcome here is obvious. As we can see here, both models reach a constant velocity of approximately negative 9.9 along with the negative y-axis. The first on the left-hand side model is the one with the initial velocity of negative 10 in the negative y-axis. The right-hand side is the one with the 0 initial velocity, but they both end up with the same terminal velocity. So as the model turns out, initial velocity doesn't affect the terminal velocity.